Hi, my name is Alice. I'm one of the co-founders of Anaxa, where we are taking advantage of the intersection of two recently developed cutting-edge technologies, quantum and blockchain, in order to secure the transmission and storage of health data records in hospitals. So looking around us, we're currently living in a connected world that's powered by the internet. But as a cost of this convenience, security hacks and latency issues are exceptionally common. As more and more IoT or Internet of Things devices are being added to our networks, both security hacks and network bandwidth latencies are increasing, which also leads to an increase in the number of corporate data breaches. In fact, as of right now, there are currently around 80,000 cyber attacks happening each day. In the healthcare space itself, over 40 million health data records get stolen each year, resulting in an overall industry revenue loss of over $6 billion. This problem scales and targets at both the industry and the individual levels. But our solution to this is a decentralized platform where records with sensitive information can be stored and secure communication can be exchanged, geared towards the healthcare space. It combines quantum properties, blockchain, and IoT into a single software solution consisting of two layers: a blockchain-based authentication from the Light Blockchain Communication Protocol, or LBCP, and also the storage of health data in order to store the health data records, and also a quantum-based verification from quantum key distribution, or QKD, in order to aid the transmission part of these records. So quantum key distribution is a protocol that allows for two ends to produce and secretly exchange an unhackable key with zero latency with entanglement. So let's call these two distant parties Alice and Bob. The advantage is that any hacker that attempts to intercept will create a disruption which stops the key from sending. So Alice, the sender, sends photons containing information to the data center, and Bob, the receiver, receives them using a basis state. If they choose any different bases, those would be thrown out, while the rest would be used to make a key where they can now publicly exchange information. So the same concept can be applied to the quantum hardware part of our solution, where we utilize QKD in order to aid the transmission process of data transfer. There will be a QKD transmitter chip that can be implemented directly onto an IoT device within a hospital, and also a receiver chip that can be implemented onto a device at the data center. So together with both quantum key distribution and the Light Blockchain Communication Protocol, they create unhackable, efficient, private, and trusted communication channels when transmitting messages and also saving files for data storage. Within a network, any sensitive information is guaranteed to be secure and communication instantaneous. On the user side, we will provide a web-based platform to upload, store, and send the health data records to the hospital or health insurance agency network. The medical personnel would first upload their user files in the EMR form in order to enable the storage of the records. They will then create a new access key in order to start the QKD link when transmitting the records to the other nodes, as well as having the option to add another user to the network and sending that user the data to complete the QKD link. In terms of other organizations within this industry, current security softwares are only limited to using machine learning to detect any anomalies or unusual code, merely playing the defense mode, and also have limitations with being unable to prevent attackers from dialing into or out of an internal network, which automatically bypasses the measure. So here we compare Anaxa with the current industry standard. We focus on the core elements of security by providing record digitization, access control, and also network speed. In this visual, we explain what Anaxa eliminates, raises, reduces, and creates in order to build a user-friendly, easily integratable platform for the securing of records while eliminating latency issues. With our target users and customers, we're specifically selling to the head of risk management, or CIOs, within smaller health insurance agencies, starting off in the New England area and also their affiliated hospitals. In our buyer utility map, we've outlined the current pain points that block buyer utilities and red ocean companies within the data storage security industry, which are most commonly in the use stage. For our business model, it's a simple three-part process. We're B2B with the quantum hardware part of our solution, and the decentralized storage component integrated with a user platform software would be SaaS-based. With our revenue model breakdown, it's based on the components when the user data is gathered, processed, stored, and encrypted. And right now, in terms of product development, we're currently completing our MVP. So in the next few months, we'll be testing and gathering user feedback, securing LOIs through partnerships, and just iterating before going mainstream. Once our product is fully developed, we're planning to first target adjacent markets for POCs in order to validate our technology before we approach our main target of health insurance agencies. And here we've listed a few companies and organizations who Anaxa is affiliated with, who will also assist us in the first steps of our product development. So with Anaxa, we are reimagining communication by leveraging quantum and blockchain for a guaranteed, secure, and latency-free network. If you're interested in learning more about us, please visit our website. Thank you.